Thanks again, Linda. And I just wanted to say, seeing that list of great programs and volunteer opportunities that that everybody has coming up, as director of the New York Master Naturalist Volunteer Program, I'm always trying to share information on training and volunteer opportunities with volunteers statewide. So anytime you have a program, if you'd like to share it with me, I would be happy to distribute that out to the volunteers and try to get some increased participation for all of you. So today I'm going to talk about AVID, and AVID is an acronym for Assessing Vegetation Impacts from Deer. And I'm going to start out, I'm going to give a little bit of background about deer impacts, and I realize that a lot of you may have a good sense already for how deer impact our forests and wildlife and how it relates to invasive species. But I also want to give you an idea of what this presentation looks like. You may have groups that you would like to share this information with, and so I want to give you an idea of what this presentation contains, and also offer it to any of you who would like to share it with groups that you work with. So for a lay audience, I titled this presentation, Are Deer Eating Your Woods? And I talk about the condition of New York's forests today, how deer affect our woodlands, and then talk about AVID specifically and how people can get involved. So what makes a healthy forest? A lot of different things make a healthy forest, but two really important components are that a healthy forest is going to have a variety of native plants and tree species, and also have the ability for a new forest to grow or regenerate in the case of disturbance. And in terms of disturbance, I mean either a natural disturbance or I could also be referring to a timber harvest, anytime that the existing canopy of the forest is removed. So many of you may be familiar with the Nature Conservancy study where they did some modeling and predicted regeneration of native tree canopy species in New York State, and that came out in 2010. And so this map really shows the results in terms of just any native tree canopy species being able to regenerate in different regions throughout the state. So any area that's in green is, dark green is very good, so that in the case of a disturbance, you would predict that regeneration would be very good in those forests. Light green would be good. The kind of pale orange color there is fair, and then red would be poor. So you can see that in the lower Hudson Valley and some of the Catskills, there are a lot of red to fair areas, and so those would be areas of special concern. So about 68% was in the good to very good range, and about a third was in the poor to fair. So that's taking into consideration any native tree canopy species. So it includes American beech as a potential regenerating species. When you change that and they looked at just desirable timber species, so not necessarily beech and things like maple and oak, then the picture becomes a lot more bleak. So a lot more of New York State is either poor or fair in terms of the potential for us to regenerate those species if we were to have a loss of the forest canopy. And so it's not just, this is regeneration of desirable timber species, but I like to say that this really also represents just general tree diversity in New York State. Would we be able to regenerate a diversity of different native tree species? And so you can see that we're really facing a pretty significant challenge in terms of regenerating our forests in the future. So to go along with this, I use this forest regeneration survey of foresters that was conducted by colleagues of mine in our department here at Cornell in 2009, where they asked for different regions, and I'll just focus on statewide for now. They asked foresters, practicing foresters, in the stands that they visited, how many of them did they see highly successful regeneration in, how many moderately successful, marginally successful, or a complete failure, and in terms of the percent of the forest stands that they saw. And you can see that statewide, 45% of the stands were marginally successful and 25% were considered a complete failure in the eyes of the foresters who were working in those stands. And they asked then, followed up with, what were some of the reasons that they thought were responsible for this happening. And the number one factor that foresters identified was deer browsing. And the second was interfering vegetation, which could mean invasive species, and it could also mean interfering native vegetation, things like American beech or hop hornbeam, things that deer don't prefer that can get established in thick and heavy stands and prevent regeneration or growth of native species. So then white-tailed deer not only have the ability to affect the forests and the forest vegetation, but in doing so, the ability to change not only the habitat for themselves, but also the habitat for other species. And they do that in two ways, by changing the forest structure and by changing the species composition. So first of all, I think a lot of us are familiar with forests that look like this, where we have missing layers of vegetation. Deer are browsing heavily. This is actually a forest in northern Pennsylvania, and quite a bit of sunlight is getting to the forest floor here, and you might expect there to be growth on the forest floor, but there's really almost nothing. And many of the layers of vegetation, ground cover and the shrub layer and an understory layer, are completely absent from this forest. This slide shows a stand in Pennsylvania where there was a harvest and some of the canopy was removed all at the same time. It's the same stand. The only difference between the right side and the left side of this slide is that deer were excluded from the right side of the picture, and they by the fence, and they were still present on the outside. So it was the same stand to begin with. A harvest happened. Where you didn't have deer, you see there's quite a diversity of woody vegetation growing up. That forest is on its way to regenerating. On the left side of the stand, you have nothing but ferns on the forest floor, ferns and grasses that have taken over. And you can see that there's a very distinct browse line, so really nothing growing up to the 6-foot height where deer can reach, and really nothing coming back in terms of the shrub layer there. So a really drastic difference. So deer are affecting the forest not only by directly browsing on seedlings and prohibiting them from growing. This slide shows actually that oak seedling on the left was planted probably 8 years before that picture was taken. You can see that it's still holding on, it's still hanging in there, but it's just not growing. It's got that little that broom kind of look, witch broom kind of look, and it's not being successful. And so direct browsing on the seedlings prohibits their growth, of course, and then they're browsing on some species that they prefer over others. And in terms of invasive species, deer tend to not prefer those species and tend to prefer a lot of our native species. So by growing on those that they, or browsing on those that they do prefer, those that they don't tend to take over, and that includes not only invasive species, but also, like I mentioned before, American beech and hop hornbeam and some other species. There's been a lot of research on deer impacts and deer impacts to forest vegetation. This slide just depicts some work that was done in Allegheny National Forest in Pennsylvania many years ago, beginning in the 70s, where they basically, they took a different approach and they fenced deer into areas at different densities per square mile. So they had an enclosure with 10 deer per square mile, 20 deer per square mile, another one with 40 deer per square mile, and another with 80 deer per square mile. And they studied those enclosures for many, many years, then removed the deer, and then continued to study them, and have seen some really interesting results. So deer density tends to impact wildflower species richness. Deer tend to really prefer to browse on things like trillium and a lot of our other native vernal species. And so as deer density increases, then you have a decrease in wildflower species richness. Likewise, they can have an effect on tree species diversity. And so this slide is showing kind of the legacy effect of deer on forest tree diversity. So basically in those same, you see along the bottom axis there, those same exclosures, this is reported in deer per kilometer square, with the same densities of deer. So basically as you go to the right, the density of deer increases. And again, those deer were kept in the enclosures from 79 to 1990. And then they went back in 2011 or probably 2010, and they looked at tree species diversity today. So that's, like that was what, 10 or 11 years after the deer were removed, and you still see a lower diversity of trees in the enclosures with a higher deer density. And of course that makes sense because trees are very long-lived, and whatever's happening to our seedlings today is going to affect the trees that will be present there decades later. And then the most, maybe the most interesting to all of you is that deer are affecting the forest by browsing native plants, and in doing so, it really causes a disturbance to the forest and allows this gap, this room, this kind of space that's not occupied and that's somewhat disturbed for invasive plants to take over. And so we wind up with this degraded plant community, things like garlic mustard on the forest floor, Japanese barberry, and a lot of other invasive species. And then also we can have these browse-tolerant native plant species that take over and may require purposeful management if we want to restore the forest, even if deer populations are reduced. So on the left or on the right, where you see beech brush on the left and you see ferns on the right, in the absence of some type of purposeful management, that forest is not going to recover fully unless we do something. And then I talk about how deer affect other wildlife by, I mentioned changing the habitat structure and composition, and how they do that by over-browsing, and then we lose those levels, those different layers of vegetation in our forest. So something like the picture on the left, where we don't have much vertical structural diversity, that basically means that we are missing a lot of different layers from the forest, versus a picture on the right where we have a lot of those layers. We still have some of the tree canopy, and we have some mid-story and some shrub layer present in the forest. And that's very important to many wildlife species, and especially to bird species. So in that same study at Allegheny National Forest, they looked at deer density historically, and whether or not that has a legacy effect on bird density about 18 years later. And so what they found is that yes, it does. The forests with many deer in the past still, many years later, have a lower bird density than those with a lower deer density. So, and that's primarily through the loss of those layers of vegetation. So birds divide the habitat vertically, and you tend to have some species, say the scarlet tanager, for example, that uses a forest canopy. You may have black-capped chickadees using the understory, and ovenbirds using the forest floor. And when you lose those layers of forest that a given species depends on, then you oftentimes don't have that species in the forest. So a nice, strong vertical structural diversity in a forest can be very beneficial to birds. In a study in New Jersey, they looked at forest breeding bird species trends from 1980 to 2005, and they found that for the most part, mid-story, shrub, and ground nesters have been declining, whereas canopy nesters have been increasing or stable. And they also reported that effect was probably as a result of loss of structural diversity from, in large part, deer browsing. Okay, so to address the issues with deer impacts to vegetation, we've been working with DEC, who funded the development of AVID, and also with SUNY ESF for the past couple of years to develop kind of a rapid assessment method for evaluating deer impacts to forest vegetation. So DEC would really like to take into consideration the impacts deer are having to our forests when they make permit allocation recommendations and decide, what the harvest levels should be in different wildlife management units, but there's not a lot of on-the-ground data available. There is forest inventory analysis data from the Forest Service, but it's kind of at a, it's not, there aren't as many, there's not enough information. There's some information, but not enough to make good decisions on a smaller level. And so we have been working with DEC to develop a method to encourage landowners and foresters, volunteers, and natural resource professionals to go out and collect data on a more local scale that can be used to kind of assess the impacts that deer are having to vegetation in those areas. So what the protocol entails is that you can go out and collect data on your own land or land in your community, and we include a protocol for wildflowers and for tree or shrub seedlings. And it's generally simpler than the more advanced methods that are typically used by foresters. So we wanted it to be something that could represent well what was happening on the ground, but also be simple enough for the average volunteer to learn and to implement without too much of a time commitment. In terms of why someone would want to participate, it's a good opportunity for some people to go out and learn about the ecology of their land, to learn about spring wildflowers, and to learn a little bit about tree seedling identification. It can help people develop an eye for recognizing key signs of deer impacts to their woods. And it can also help if someone's interested in participating and contributing to this effort to kind of document health of New York forests and track those changes over time. So contributing to part of a statewide team effort. I had a volunteer, a master naturalist volunteer, who implemented the protocol this summer, and she and her father went out to their woods, and they thought their woods were fine before they went out, and they reported back that it was very eye-opening to them when they actually went out and looked at the individual seedlings and looked at what was growing and what was not growing in their forest, and that it had been kind of caused a sea change in the way that they were viewing their own forest and the impacts of deer there. So the AVID method focuses on wildflowers or tree and shrub seedlings. So two different methods. The first method, the spring wildflower method, focuses on 4 species that are pretty broadly distributed and also are known to be eaten by deer and maybe be good indicators of deer browse impacts. The first is any of the trillium species, so that's not just one species, but any trillium, Jack in the Pulpit, Canada Mayflower, and Indian cucumber. And a lot of these have been used in the past as deer indicator plants. Jack in the Pulpit is being used in Pennsylvania by the Pennsylvania Bureau of Forestry, who is implementing a protocol that's somewhat similar but a little bit more involved than the one that we've developed. But Jack in the Pulpit, I think of that as more like the beach of the wildflower world. So it's not necessarily preferred by deer, but when that's all there is and you see that it's being eaten by deer, then that's a really good sign that things are pretty stark in your forest, and that's maybe the only thing left, and deer are having a pretty significant impact. The other advantage to using spring wildflowers is that they can have a quicker response to a decrease in deer browsing than seedlings. So sometimes if you make a change and you reduce deer numbers, you see them rebound more quickly than you would see a woody seedling respond. And they also will respond in the presence of ferns and other interfering vegetation. So because they are growing early in the spring, before a lot of things leaf out, or before ferns are fully up and growing, they still will respond, whereas a seedling may not. The shading from those plants may still reduce tree seedling growth. So, so the wildflowers do well even in shaded conditions and even in the presence of other interfering vegetation. The second method is using woody seedlings, and it can be shrubs or tree seedlings. And we ask that, if possible, that participants try to select one species that is not a preferred browse species and one that is a preferred browse species. So, for example, if you had the opportunity to measure and monitor sugar maple and then maybe American beech. Sometimes you won't have that opportunity. Sometimes all you have is something that's not preferred. You only have beech remaining on the property, and that's fine. But if you can do both, it kind of gives you a different picture. If you have American beech or if you have sugar maple and it's being browsed, that tells you one thing. It tells you I'm having a hard time growing things that deer like to eat. If you have beech on your property, and it's being browsed, then that tells you another story. That tells you, wow, I only have things that deer don't prefer, and even those aren't growing. So it can help give you a little bit more refined picture of what's happening in your forest. Participants are asked to focus on woody seedlings that are greater than 6 inches tall and less than 4 feet, and ideally less than 3 feet tall. And that's because seedlings that are really small, you wouldn't expect them all to survive anyway, and so you want something that you'll be able to tag and measure and follow over, say, a 4 to 5 year period. And same thing with the upper limit. You want something that hasn't grown past the height where deer can reach, because once a seedling makes it past where deer can reach, then it's kind of it's free. It's made it past the deer challenge. So you want to use something that's short enough that you'll have the opportunity to track its growth over at least a couple of years before it's beyond the height where deer can reach. So there are a number of steps, and I won't go into too much detail, but you go out and you select a stand on a property. If you have multiple stands, a stand is an area with distinctly different conditions. So you might have a hemlock stand, and then you might have a northern hardwood stand. And you'd want to focus on just one stand to implement the entire protocol that you're going to use. If you want to do it in more than one stand, that's fine. But you just want to make sure that you have enough seedlings that you're going to monitor per stand. So you can select one or more stands and then decide on whether you want to use a seedling or the wildflower method. So if you have a closed canopy, which a lot of our mature forests these days do have a rather closed canopy in shaded conditions, then the wildflower method, if those wildflowers are present, might be ideal, because again, they're going to respond to deer browsing pressure, or you'll see a release, or maybe I should say, you will see them growing when there's a release of deer browsing pressure, even when there's shade present. So you'll be able to tell if there's a change in deer impacts. And then if you have a canopy or sub-canopy cover that's less than 50%, so a more open forest, then either method will work. And I will say, though, that for some people, wildflowers are just more attractive for them to go out and measure, and they have more interest in that. And for other people, they're more interested in monitoring tree seedlings. And there are some seasonal availability considerations as well. So for spring wildflowers, ideally you would be monitoring them when they're blooming. So that would be mid-May to mid-June, before they start losing their natural height and kind of senescing. Or you could continue to do some measurements even though they're not flowering. You may be able to tell whether or not they've flowered. And you could into August, but it's really not ideal. Whereas for woody seedlings, you can monitor those anywhere from June until when the leaves fall off in the fall. So that's a consideration as well, the time that you have available, and really there's a kind of a bigger window for monitoring woody seedlings. So within a given stand, you set up your monitoring plots. Here's a plot is pictured here. You basically put a stake in the center. You number that stake. You put a pin flag in each of the 4 cardinal directions and create 4 different quadrants. That helps you keep track of the individual plants by knowing where they are, generally within which quadrant. Ideally, you would put in 6 plots, and each would contain at least 5 of the seedlings that you're targeting. So say you were doing sugar maples, each plot would contain at least 5 sugar maple seedlings that you would tag and measure and track over time. And you'd be looking to mark and measure 25 to 30 seedlings or 25 to 30 total wildflowers of the same species for each site, so for each stand. So if you had 5 seedlings for each of 6 plots, that will give you 30 to track over time. We also encourage people, if you have a deer exclosure, or if you could create even a couple small exclosures around a couple of plots, we encourage people to do that, add a couple extra plots and track those as well. And that gives you an idea of what you could expect to be seeing on your site in the absence of deer browsing. And it's also a really great visual just to see the difference between what's happening inside and out, and a great educational tool as well for others. So for the spring wildflower method, you mark the wildflowers and you measure the height of each. So I'll show you a picture of the markings that we use for the wildflowers. You measure the height from the ground to the stem, at stem level to the highest whorl of leaves, and you measure the natural height rather than standing it up manually. And we've been experimenting with different ways to mark wildflowers, and it can be very, very challenging and challenging to relocate. So we've been using sod stakes, pictured on the left there. You can get them at any Lowe's or Home Depot. And we've been using tree tags that we've ordered, metal numbered tree tags. And so basically we slip it through the sod stake and place it down next to the wildflower. And then we've been double marking it with, say, those are just golf tees on the right that are tall and kind of brightly marked. And that can help us to relocate the metal tags after the leaves have fallen the previous fall. So we're still experimenting. I don't think we have the perfect method for tagging wildflowers yet, but this method works fairly well. The metal tags definitely stay in well, and but there is some challenge to relocating them later. But we're working on that. All right, then the second method with woody seedlings, it's basically the same thing. You tag the seedlings, and if you look down on the right here where you see the seedling coming up and there's a yellow tag that says 1080. It's yellow. It's like a zip tie almost, and we have ordered pre-numbered ones, and we have many, many thousands of them at this point. So we're distributing those. If you or someone you know would like to put in AVID plots somewhere, please contact me, and I can share some of those tags with you to be used. So for seedlings, we measure the height again from the ground at the level of the stem base to the end of the newest woody growth. So not the end of the leaf, because leaves come out different locations each year, and they may be sticking up higher or lower, but we look for the end of the newest woody growth. And we measure, again, the natural height rather than extending it manually. So there's just a close-up of the tags and how they work, and we attach those at the stem base. That is a very tiny seedling. We normally wouldn't choose a seedling that small, but basically that gives you an idea of what it looks like. And they're very easy, lightweight to carry around, easy to put on, and they seem to be lasting pretty well as long as they're fixed tight enough to the stem. We don't want to make it too tight because we don't want to block airflow to the stem completely, but they do seem to be working pretty well. So we have 2 options for collecting and submitting data. The smartphone apps are not yet available. We're working on them. They're kind of being beta tested right now. But we do have also paper data forms, and we have the website aviddeer.com where everything can be submitted online. We ask people to collect data once a year within 2 weeks of the initial date that they take the data, so that it represents 1 year's growth. And we ask for a 4-year minimum commitment to see a change. And so you can share data collection responsibilities with others. So say you work for a land trust and you want to put in plots on your property, but you don't know that you necessarily can be the person to revisit that each year. We do have a method for sharing that data online with other people in your organization so that you can share that site. So I just wanted to give you a picture of what the AVID website looks like. AVID is at aviddeer.com, and we have hopefully all the resources that you would need to be able to implement AVID there. We have information. We have the whole manual, the user manual. We have all the background information, talking about how to look for a site and establish your plots, how to tag and measure everything. And here on the home page, we have walk you through steps to getting started. So you can register at aviddeer.com and create a user ID and password, and learn the methods you'll be going to use, and then you can enter data through the My Data tabs. So there is also a recorded presentation about using the AVID method, and so that's a webinar, and I've posted the link at this site, so you can go through and see the more detailed presentation. And then this is just an image of the My Data area. So you can see under My Sites, I have a lot of different sites that data has been entered for here. And so you enter site level information that you collect, and then once you enter the site level information, you're taken to another screen, and you can see here where the woody seedlings, there was information collected on. So tag 4421 is a striped maple. It's in the northwest quadrant, and then there was one measurement taken. And so you can see, let's see, I'll go back one. Once you click on one of those, then you can go and there's an area where you can enter your actual measurements, your height measurements and whatnot for the individual tagged plants. So, you know, somebody's monitoring and they find out they do have deer impacts, you know, the question is always, now what? Now what can you do? And so, you know, we have, some people have more options than others. You know, one of the options is reducing deer numbers when possible, and certainly before a timber harvest happens. If you're using AVID and you find out the deer impacts are very significant and it doesn't look like regeneration is going to happen very easily, and that's something to consider before you open up the canopy and, you know, remove those canopy trees, especially if you're going to have a very heavy harvest. You want to make sure that you're going to be able to regenerate that forest before you have your harvest. And so this can be a way of kind of figuring out ahead of time, you know, well, what are my chances and what do I have to do before I have a harvest to kind of give myself a better shot at having regeneration happen at my site. Other things to consider are fencing to exclude deer, and even small exclosures can be beneficial. And then there are some other ways to try to manage deer impacts. We've been doing a lot of research on leaving woody material following a harvest and the potential effects of mitigating deer impacts in that way, especially on sites where maybe deer impacts are not terribly heavy. Okay, so then if people continue to monitor and submit data, then it will also help DEC to be able to assess the impacts to forests on a larger scale in a given region. So we're trying to get a critical number of people in the different wildlife management unit aggregates to participate. And success looks like something like this. Success means seeing changes on the ground where wildflowers are appearing. They're taller, they're flowering more often. If you have an exclosure, the outside of a fenced area begins to look like the inside. And seedlings, especially those that are preferred by deer, can grow past the height that deer can reach. So that's what we're hoping for someday. There's a lot of effort, maybe easier in some areas than others. But we're hoping to get people to participate, to become aware, more aware of the impacts that are happening, and to be thinking more proactively in terms of deer management and forest management broadly. So in terms of resources, we have aviddeer.com. You can check the website for notification that smartphone apps are available. We are planning to have a number of trainings this spring. We're hoping to be able to start planning as soon as our new contract comes through, which should be any time now. We definitely have some happening in the Hudson Valley that we have lined up already, and there will be other opportunities throughout the summer. So if you want more information, please contact me.